Hi, good evening to all. Tell me, am I audible and visible to everybody? I'm looking at the chats. Tell me, am I audible and visible to everyone? I'm looking at the chats. Okay, okay. So now agenda, you everybody already knows that because after this series, what we want is that no matter what interview is, you should be rocking there, right? So again, the whole series will follow, which you know, right? We already discussed in the previous classes as well. And again, today we will solve a problem which has been asked in AA. You know what is AA? A Apple and Adobe. And why is this problem statement is important? Because recently they have asked this question, and the higher chance they can also ask in the other interview as well, right? So no matter for which company you're preparing, question is important for you. Again, before just jumping on the solution, what I'll tell you to read the problem statement thoroughly. Okay, we'll take a moment, we'll read the problem, and we'll understand. And again, trust me, every easy problem has an optimized solution, every tough problem has an easy solution. Okay, so perfect number for today's, at least number is perfect because I heard nobody is perfect. What do you believe? Hi, Basnavi. Hi there. Right, so read the number, read the question like perfect number. Okay, so finally there exists something which is perfect. So now a perfect number is a positive integer that is equal to the sum of its positive divisors. Means if we have a particular number, we can divide it by a positive divisors, then excluding the number itself. A divisor of an integer x is an integer that can divide x evenly, means it can keep dividing, right? Again, given an integer and return the true if n is a perfect number, otherwise return false. Right, so what we need to do is that we need to find the divisor of a particular number, all the positive divisors, then we need to figure out the sum. If this sum equals to that particular number, will return true, otherwise it will return false. I hope you are getting the logic, right? You're getting the logic. And trust me, there is something hidden. Okay, I'll tell you, which you can in the solution itself, you'll figure it out, right? But before we move on the solution part, I want that you understand the problem statement first very carefully. So let's say they are telling like you have a number 28. So what they're mentioning is that you need to find out all the positive divisor of it. So let's see what are the divisor are, right? So can we divide 28 by 2? Tell me. Yes, we can. Okay. Again, can we divide 28 by 4? Yes, again we can divide. Again, can we divide 28 by, we could divide by 2, we could divide by 4, we could divide by 7. Any other number? Anyone can suggest to me? 7, it's already there. Right, okay. I'll write here once, okay? I'll write, then I'll explain. Okay, so 7 4s are, Ria is present today. Okay. So now, again, we can say we can divide it by 14. Okay. So now here this will become 2. Yes or no? So what we are doing is that what we can assume is that we can run a loop, right? From where? From 1 to n, and we can keep divide. We can check that number if a particular number. Let's say I to run, right, and I will start from the 1. So now 1 to n. If that number is divisible by I, right? In that case, what we can do is that we can add that particular number in a sum. So for example, I was running a loop from 1 to n. Okay, I was running a loop from 1 to n, and now what I'll do is that if that particular number is dividing or 28, in that case I'll add that number to a particular sum. Okay, and in starting I'm assuming sum is equals to, 0. So now let's take an example of 28. Okay, so now 28 divided by 1. It's a true? Yes or no? So now the value of sum will be, 1. Again we'll see, is 28 divided by 2? Yes. So the value of sum will be 3. Again we'll check, is it divisible by 4? Yes. Means 3 won't, right? So in that case, we'll divide by 4. So yes, it is divisible. Again, we'll try by 5. Is 5 dividing the 28? No, it's not, right? So again, we'll get the another I plus plus. You remember the loop? Remember the concept, right? So now again, we'll check for 5. It's not. Again, we'll check for 6. It's not. Again, we'll check for the 7. Yes, 7 can divide 28. Yes or no? Means if you'll write 28 modulus 7, you'll get 0. Yes or no? You'll get 0. So now again, for the next 14, add these numbers. This becomes 3. This becomes means whole 7. Do I need to repeat it again and again? Or I guess you people can understand it easily. Not a tough mathematical expression. Yes or no? Okay. So now here 1, 2, 3. These 3 for 7, 7, 7, 14, 14, 14, 28. So we're getting sum is equals to 28, right? So if the positive divisors, we get the sum of the positive divisor, it becomes to the original number, which means number is a perfect number. Number is a perfect number. Okay, so finally there exists something which is perfect. Yes or no? There exists something which is perfect. Okay. So now I hope everybody had understood the problem. What is the problem statement, right? Everybody knows it. What is the problem statement? And again, yeah, this series will going to help a lot of people. And I want that you should also help your friends, because that will not help me a lot. Anyhow, I'll get the salary which I'm getting. But if maximum people will be joining these live classes, they will get a lot of help. Maybe they'll be securing the packages of very very higher numbers. So now I'll go to the coding window, and then after writing solution, because that's what everybody thinks about this solution. Okay, but now after writing this solution, I'll tell you the another way as well, the optimized way. Okay, so now here what I was assuming is, I was assuming that I can have an int. Let's say that I'm defining sum, and starting sum can be 0. Okay, now I'll take a loop. I'll take a for loop. I'll write here int I equals to 1, because not 0. 0 will not divide any number. Now I should be less than what? Tell me, num, because excluding the number itself. Okay, excluding the number itself. Look at this. Read this statement. So which means we will not divide by num. Okay, now I plus plus. Right. So that's a loop syntax you know very well. I don't have to repeat it. So if a particular number divides it, num modulus, if num modulus what? I, right? Because I will keep, first time I is 1, then I will 2, then I will 3, then I will 4. We'll keep checking, right? If this is divisible by I, in that case, that is a positive divisor, yes or no? So we'll add this into the sum, previous value of sum and the new upcoming value, right? So this will keep happen, and at the end we can compare, is my sum equals to what? The original number. If this is equal to the original number, we can say it's a true, otherwise it's false, right? On the same place defining the meaning. Making sense to everybody? Tell me here. I want like you feel this as an offline class. Don't think it's a YouTube live. Huh? I want some interacting, some people are interacting. Interactive students I like a lot. Okay. Okay. So now I'll run this. That's what everybody can think about, right? So it's a basic solution, not an optimized one. Everyone can think about a brute force now, but look at this. We are taking a lot of time. Can you see here? Can you see here, Sanket? Can you see here, Ria? Fact Spark, Vaishnavi? Can you see here? It's a very, very, very large time, right? Yeah, correct, Prince, right? So it's taking a lot of time. So can we optimize this? Can we optimize this? You remember the last problem we have solved for the prime, right? Last problem we have solved for the prime. You remember? In that time, what I was telling you, that if a particular number is divisible by, so in that case, it will also divisible by the square root of, less than or equal to the square root of a particular number. What I mean is, you can see here one thing. Okay, you can see here one thing. As of now, what we are doing is that, we are doing this. We are dividing by 2, we are dividing by 4, we are dividing by 7, we are dividing by 14. And again we are checking till we are 27. So tell me one thing. Can a particular number divided by the half of it, more than half of it? Can you divide 8 by 5? No. a particular number can never be divided by time limit exceeded. No, Sanket, not exceeded. It has been executed, taking a lot of time. Okay, so now the agenda is that we cannot divide any number more than the half of it, right? So first thing. So is there any other approach as well? Yes, here is. As you can see that when we were dividing by 2, we were getting the another value, the another multiple of it, right, which was 14. So we don't have to divide it by 14 again. Again, if we were dividing by 7, 4, we were getting 7. So again, you don't have to divide it by what? 7 to get 4. Yes or no? What we can do, if we are dividing by, let's say, I. Okay, we are dividing by I. So at initially I was 1. Okay, at initially I was 1. So I was dividing what? I was dividing 28 modulus 1, which was equals to 0. Right? So I was adding 1 to the sum. Again, when I become 2, so I was dividing 28 modulus 2. Yes or no? Which is equals to 0. Right? But again, if I want to add, so in sum here, what I will add is, I will add 2. Previously it was 1. 1 plus 2 becomes 3. Parallelly, I can add 28 divided by 2, which means 14. Means parallelly, I can add 14 as well here. Make sense to you? We can add 14 here as well, because if it's a divisible by 2, then the multiple of that will also divide once. Any other will divide in future. Again, similarly for 7, if we were dividing by 4, we were getting 7, which means 7 will also divide 28 to get 4. Yes or no? So, at the place of repeating it, what we can do, we can utilize it. At the same place, we can add in sum here, we can add 2 and 14. Here we can add in sum 4 and 7 together, right? And again, we don't have to go more than this. More than what? More than the square of that number. Okay, so what I mean is that you don't have to check numbers more than let's say if I say 5, because the square of 5 is 25, or the square of 6 is 36, right? So 36 is greater than 28, right? So you don't have to check more than 6. You don't have to check more than 6. You'll get all the numbers. Okay, so which means that if you want to get all the positive divisors, you just have to divide that particular number less than the square root of that particular number, less than or equal to the square root of that particular number. You will get all the divisors. Okay, and this is the optimized solution. Okay, please change the pen color. Okay, Prince, I'll change it. Okay, don't worry, I'll change it. In the next slide, I'll change it. Okay, red you don't like, right? Okay, so now here what we can have, again I'll dry run this as well. Okay, I'll dry run this as well. So now here what we were saying is that we don't have to run till I. We can run this to the square root of a particular thing, right? So here is how we can get the square of it. We can get the square by multiplying it, right? Yes or no? But again, what will happen if you are adding? So what will happen, when we will divide 28 by 1, you will get the 28 as well. But we cannot add 20 because numbers will be excluded. So here I'll start sum by 1. But wait, I'll dry run this to make you understand. Okay, it is superintendent. Here you can have a confusion. I know you can have a confusion here. Why I'm doing this? Okay, so now here I'm adding sum, and again here I'm adding sum. But wait for a minute. You'll get this. Okay. Now here simply in the same way I'll write sum plus means previous sum plus the number divided by I. Okay, now you'll get the optimized one. Previously the time complexity was that was we can say linear, right? Big of n. Now the time complexity is the square root n, big of square root n, which is very less than the previous one. Now if I will run this, you will see something. Oh no, what is the problem? It's mentioning like okay, we have to handle a test case now. If the num is 1, that should be false. So we'll handle it. If num is less than or equals to 1, because negative numbers cannot have a positive divisor. So in that case, we'll return the false. Okay, we will return the false. Oh, I haven't written return here. Now what I'll do is that I'll submit this. Okay, and I'll write on this to make you understand how this solution is working. Now look at this. 1 millisecond. Previously it was 2100 something. Have you seen this? How much has been changed? A lot. And this is the one of the best optimized solution you can have. Okay. So now you get this, but how is this working? Okay, I've explained you the logic, but now I want to write on this also, by which you can understand more better. So now I'll take a new slide. I'll change the pen color as well. Okay. Yesterday I was using yellow. Was that fine? Okay, see, maybe you'll feel like it's fine. Yellow. Okay. So now here how our solution is working, we are just first we are checking like if n is less than equals to 1, which means all 1 and the numbers less than 1. Okay. Okay. Now in that case it will be false. Yes or no? In that case it will be false. Make sense? It will be false. Again, we are taking sum equals to 1. Why? Why? I'll tell you why. Just wait for a second, okay? And then what we were doing is that we were writing for int and we are starting from I equals to 2. Just wait. You'll get why I'm writing this 1. Okay. Now I'm multiplying I by I, which is less than n and I plus plus. Okay, now here what I'm doing is that I'm writing that if number is divisible by I, only in that case do one thing. Do what? Do one thing. Sum plus is equals to I and sum plus is equals to num divided by I. So how is this working? Okay, and at the end what I was doing is that I was returning num equals to sum, right? That's what I have done there, right? But how is this working? Okay, now let's take an input which is 28. That's what was given, right? Now here we'll start with sum, step 1. Okay, we'll start with sum which is 0, which is 1 as of now. Why? I'll tell you, just hold a minute. Now again the starting value of I is 2. Yes or no? For starting value I is 2. So now here I is what? I is 2. Again check, is the 2 multiplied by 2, which means 4. Is 4 less than 28? Yes, it is. Now come here. Check the condition. Is 28 divisible by 2? Yes, it is. If this is divisible, then go here. Then the value of sum will be increased by what? Sum, the previous one, plus what? The new value. Why I have assumed the sum is 1? Because every number is divisible by 1. So we don't have to divide it here. To avoid one more problem as well, like again, this is right. And again we are writing sum, which means you remember in the last slide, if we were dividing by 2, we were getting 14 as well. So we were adding it as well. Yes or no? So now here, I'll take the pen again. Now here, what I want is that sum is equals to previous sum, which is now 3 plus what? Num divided by I. And num is 28. 28 divided by I is 2, which means 14. This will become 3 plus 14. You will get 17 here. Yes or no? In the next round, what will happen? The value of I will be increased by 1, which means now this has become in step 2. The value of sum is 17. The value of I is 3. Okay. Now check. Is 3 less than, 3 multiplied by 3, which means 9. Is 9 less than 28? Yes, 9 is less than 28. So in that case, we'll check. Is 3 dividing 28? No. So which means this condition will not execute. We'll do I plus plus. I will become 4. Yes or no? Now I is 4. So now again, the square of 4 is 16. Is 16 less than 28? Step 3. Sum is again 17. But I is 4, right? So it's 16 less than 28. Yes, it is. Now come here. Check in the condition. Tell me, is 28 divisible by 4? Yes, it is. The condition is true. This condition is true. Yes or no? If this is true, then we'll increase the value of sum, which is the previous sum plus the I, and I is 4. Again, if we are dividing 28 by 4, that comes 7. So which means 7 will also divide 28 to get 4. Yes or no? So at a time we can add both the numbers, and that is the logic here. You're getting the point? Tell me everybody. Tell me, I'm reading at the chats. I'm reading the chats. Tell me, you're getting the logic? So now here we can add in the sum itself again. The sum of this will be 21 plus 28 divided by 4, which means 7. So now 21 plus 7. This becomes 28. Again, the value of I will be increased by increased by 1. So now the value of I will become 5. The square of 5 is 25, which is less than 28. Yes or no? Again, 5 cannot divide 28, which means this condition will not work. Again, I plus plus, I becomes 6. Now the square of 6 is 36, because I told you no number, the numbers which can divide it will be the less than or equal to the square root of it, because we are covering the second half by dividing that whole number by I, right? Second step confused. Here in second step now I was 3 and previously sum was 17. So now again, if you will divide this 28 by 3, you will not be able to divide, because anyhow what you remainder you will get 3 9 are 27, you will get the one remainder, not 0. So which means this if condition will not work. Okay, so we'll go to the end of the loop, and again the value of I will be increased from here. That will be 4, and we come to the step 3. Is it clear, Prince, now? Sir, please explain that sum by I. Previously you understood that. You understood what? I have told you in the previous one, because we were checking what? We were dividing that particular number by, we were checking that particular number by I, and if this is 0, so it's a positive divisor, yes or no? So that time we were adding to the sum, yes or no? We were adding to the sum, but as you can see, we want to optimize it, right? We don't want to, check from 1 to n. This can be done by checking the I square less than n. Why is that? If you will divide, I'm taking example of 28 again. If you will divide 28 by 2, that will come 14, which means you don't have to again check with 14. Any of 14 will divide 28. So you can do at the same time. So we are adding sum, the previous value of sum, which is 1, and the current value, which is 2. This becomes 3, yes or no? Again, in parallel, we can add 14 as well. Okay, ex1, you're getting this? So now parallelly we can add sum equals to previous sum value, which is 3 plus num divided by I, and I is what? I is 2, which means we'll get 3 plus num is 28, and 20 divided by 2, which becomes 14, 17. Okay, now it's clear now? Tell me, it's clear to you? I guess it is. Okay. So now for the similarly, right? Again, you don't have to check numbers more than the square of. Okay. Okay. So that's the optimized one. Okay, Sanket. Okay, now I guess everybody has understood this problem. And I'm glad. And I strongly believe once you will complete this series, even if you're studying in BTech, you can have a massive opportunities. The coding interviews will help you a lot, right? And again, if in the final year, then keep applying from the career pages. Okay. Actually, Prince, to optimize it, because anyhow previously we were checking from 1 to n. Now we are checking till where? The square root of n, right? Okay. Cool, Prince. Cool. Okay, now I'll wrap this session. I hope you enjoyed this. And again, do one thing here to keep continuing this series. I want engagement. I want more people to support it. Okay. I hope you guys understand the situation, right? So keep sharing the lives to the other people as well, because they can also get profit. And keep applying from the company career pages to get the opportunities. And rock there. Have greater and greater packages. Okay. Now number is perfect. Now you become perfect. Bye bye all. Bye bye. I'm leaving now. Okay. And every day I come on the same time, 6:15. Okay.